Yeah? Okay, so the author is saying that some of these are valid and some of them are invalid. That's good. Again, stop me if you find this in your notebook. Wouldn't be a total waste of time, but not the best use of it. Yeah, I'm going to try something different. Go to this one. Pretty sure we didn't do this monster. No yawning. Have to pick it up in the next column. Holy cow. This is number 9 on page 386. But wait, there's more. See, is this going to pose big problems? Yeah, it might. That's okay. There's a way to resolve it. Just have to figure out how. Always a way. Did I copy it right?
Mm-hmm.
Just curious, how big would the long truth table would be? How many rows?
Two to the 8th power. $256 rows.
No, I'm not really sure I figured out how to do that. Can you write those out for me?
What, the long truth table? Yeah, this one this one is going to pose some problems. We're not going to have much to work with. And I'm guessing that we're probably going to try to identify some area with the fewest possibilities, like we did last time. See if some areas have 2 possibilities and some have 3. We definitely want to go to the 2. Now, the samples on your test that I'm demanding you do this short procedure. Yeah, it can have this many letters in it, different letters. Because see, I want to make sure you're not doing the long truth table, which anybody can do. So I have so many simple statements in it that it would be prohibitive to do. How long do we say that was? 256 rows? No, you're not going to want to do that. Okay? At this time, let me tell you how I'm going to score this on the test. It's unusual and confusing to some students. I can't ask you about your truth values because, especially when they get this long, if there's a contradiction to be found, it could be found in any one of a number of places, right? And if there's no contradiction to be found, there's probably several rows on a truth table of this size that would prove invalidity if it is invalid. So I can't ask you what your truth value assignments are, but this is definitely the most involved procedure we've done. I can't just I can only ask you about valid or invalid. See, but I don't want to make it one point, because it's a lot of work. So I make it worth some number of points. See, like maybe 3 or even 5 points. But it's a Scantron test. Like the last time, you're going to do a lot of work. I'm going to ask you to answer things true or false about your work. So to make this worth, let's say, 3 points, my instructions will say, do a short truth table proof of this argument, validity or invalidity. If it's valid, mark true for 3 consecutive answers on your Scantron. So let's say they were 13, 14, and 15. So I'm actually going to have those there on the test, and the instructions say mark true for 3 consecutive answers. That would be, in this case, 13, 14, and 15 on your Scantron. If the argument form is invalid, then mark false for 3 consecutive answers. So this is confusing to some students. Do you think you get it? The only other way I could do it is go through them by hand and add points to your total, and I really don't want to do that. Okay? Let me point out something else about this. Some enterprising students my instructions also say you must answer, true or false for 3 consecutive answers. Because some students, and this is real nice and logical, but they're going to reason, I have no idea how to do this. So I'm going to get at least 1 point out of this. Maybe 2 if I'm lucky. You know what I mean? Yeah, you can't do that. They're all wrong if you do that. It's got to be 3 T's or 3 F's. I'll remind you that again before the test. Let's see if this can be done. I don't think this is going to be easy. That's nice. That's no help. That's not going to be any help. That's not going to be any help. That's some help. Not that. That could be some help. That doesn't help. See, we can't start with our conclusion. I see 1, 2, 3, 4. I see 6 symbols. 6. Whose truth value we're certain of. From top to bottom, what's the first thing you come to?
Okay, so on the first premise, both horseshoes are true.
Yeah. It's the only way the dot can be true, right?
Right.
Fortunately, that doesn't help us with those antecedents and consequence, does it? No, it doesn't.
The fifth premise, same reasoning as the first.
That is true.
And the seventh.
This is not going to be fun. I think the first premise might be an interesting place to start. It's going to take some.
I think T in the first premise should not be false. So it has to be true.
If that's so, let's see why not. Ooh, do I want to do that? Yeah.
And then
Let's see. To make S horseshoe T true, we have these three choices.
Wait, it could be.
That, that, and that. Agreed? To make T horseshoe S true, we should have three choices. Oops. Is that what you were talking about?
Yeah. But then,
Okay, are any of these contradictory? In other words, are any of those three choices have opposite truth values for either T or S? Because you can't do that. T
Yeah.
true, T true. Oh,
the
see?
middle one doesn't work.
That's not good. Can't have that. How about this? That's good. Do we have opposite truth values for S in either of our horseshoes? No. So again, we only have, I would say if we try these two combinations, where, what do we have? S and T are both true, or S and T are both false. One at a time. See, if we're able to complete this with the first assignment, we're done. If we run into a contradiction, only have to do it one more time. Thank you. You guys know what we're going to do?
I'm gonna run through what T's.
Okay. Let's try true first. That's a true horseshoe. That's a true horseshoe. Transfer. See, this is going to go down pretty quickly in either case, both true or both false. I'm going to complete transferring. I see that some truth values have become apparent, but don't forget the transfer. Did I forget anything? Any T's or S's? No. Okay, well, I see a couple symbols that can be determined right now. Maybe the most obvious is that curl of T, right? What can you tell me about that dot? Let's stay there. When something opens up in a premise, let's not start looking elsewhere. Let's take care of everything that becomes apparent, like, for example, in one premise before we start looking elsewhere. I know what that is. We'll get to that later. Let's stay in this premise. What can you tell me about that dot?
False.
That dot is false. Everybody get that? Because one of the conjuncts is false. That's it. It's done. What can you tell me about that curl? One false conjunct determines a false dot. So what can you tell me about the other side? And what can you tell me about you? No, I mean you. No. I think we can still stay there. We're trying to preserve are we transferring anything? No. Trying to preserve a true wedge. Right? One side is known to be false. What had that other side better be?
False.
Trying to preserve a true wedge.
Has to be true.
One side is known to be false. What must that other side be?
True.
And now does you matter here?
Right.
Has to be true.
Yes. Still, I don't have to go back and change that. Doesn't matter what U is over there. Okay, I think that we can transfer U's truth value here. See, this is gonna go down pretty quickly. There's a U. And let's see, done that. Now back to this wedge, I suppose. Or we could do that curl. I'm gonna go from top to bottom, your choice. That's your choice.
That's true.
That's a true wedge. We're trying to preserve this true wedge. So what can you tell me about that one?
Doesn't necessarily matter.
Well, it absolutely doesn't matter. And therefore V. You know what? You know, this happened before. We should say I know that wedge is true, but it doesn't matter what V is. Because don't we know that wedge is true from you? Okay, sorry about that. It's true, the wedge doesn't matter for this reason. But since we do know its truth value, I think we should stick it in there. Let's see. We never determined a V. Do we have any other U's? Well, down to the next premise. What can you tell me there must be the case?
Curl is false.
Curl is false. And then what can you tell me about that dot
Which
over
means it has to
there?
be true.
I don't think so.
Could be false as well.
Well, so therefore,
Yeah,
what about that dot?
doesn't matter.
Huh?
Doesn't matter.
Doesn't matter.
Because it has to be false.
Well, we're trying to keep the horseshoe true and the antecedent is false. That's a true horseshoe regardless of the consequent. So if the dot doesn't matter, what can you tell me about both W and X right there in any case? Just in that case.
Doesn't matter.
They don't matter. It might matter somewhere else. I see that, oh, there's some X's. Okay, what are we doing up here? I think I see something in this premise.
The curl has to be false.
This curl?
Yeah.
And therefore, what can you tell me about V?
False. Must be false.
V has to be false. There's a V. There's a V. See, this is all coming down.
It doesn't.
The wedge is true.
Where?
On the fifth premise. 1, 2, 3, 4. Yeah.
We don't have a wedge in the fifth premise.
I mean, the curl. I apologize.
Yeah, this curl right here? Yeah, it's true. What can you tell me about this curl over here?
Has to be true.
Yes.
So
Everybody
why-
understand why?
So why can be false?
And how about why?
False.
There's a Y.
But,
Did I make a mistake?
well, just if we move the F down to the B in the last premise, don't we already know that we're on the wrong page?
Why?
Because that can't be false. No, it's okay, sorry,
That's okay. We're even. So the curl of Y must be true, right? In that same premise. What is that, number 6? Let's see if we know anything there. Yes, we know what this curl must be. Wait, no, do we? No, we don't know that. What am I talking about? If only we had X.
Wouldn't we have to jump to the seventh premise and finish it?
This one right here?
Right.
I think there's nothing left to do, is there? Oh, Z. Thank you. Sorry. Now you're one ahead of me. Z has to be what? That'll work. How about this? Z. Therefore, x there's an x. Aha!
So that's it.
Here's an x here too. The curl of x is true. Right?
So
And tell me about this horseshoe.
this is true.
And have we justified this?
Yes.
Guess what? You have to try it with
With the.
two falses. I think you should do that. Yeah, it's important. It'll reinforce that that's what you have to do on the test. Do you all get why? No? You said no? You said yeah.
Well, you said we should only do it if we found,
Oh, did I get it backwards?
but yeah, we actually finished. We found the mistake.
Oh, wait.
Well,
No, there's no mistake.
well, we found the invalidity.
Right, right. Ooh, maybe
So
take
I
another
have 2
break.
points. I have 2 points.
I'll have to bring in a tip jar. Every time you guys catch me in an error, I'll put a buck in there. Get you some ice cream.
You can just get us all ice cream
Yeah.
and not worry about it.
So, for those of you playing at home, it required that we tried, in turn, 2 sets of truth values for S and T. One in which they're both true, one in which they're both false. But when they're both true, we completed these assignments. Therefore, there is at least that invalidating row on the long truth table. Yeah. It's if we had found a contradiction, we would have to try substituting false for both S and T. So when I mentioned this like 3 minutes ago, I said it backwards. Thank you, sir. We don't have to do it.
This is valid.
This is invalid.
Okay, right.
Yeah, this is invalid. We have found an invalidating row that exists on that 256.
Right, yeah, that's what we just did.
Yeah. Well, that was fun. Were you guys able to follow all that?
It's exhausting. Yeah.
It's exhilarating. Exhausting. It's exhilarating. Did you feel that tingle? Tingling. Well, I wonder if anybody wants to regale us with your mastery, the subject matter, by doing one on the board.
Is it gonna be that hard?
It won't be quite that long. Well, that's not good. What's that other page we were looking at? Oh.
All this a little bit new.
Yeah, I bet I can't get somebody to come up and do this one. Oops. What do you think? Somebody want to do that on the board? This one's gonna be easy. Look at that. It's gonna give you everything you need to know, that conclusion. We had a couple people last week do it on board. I know you can. Go.
Let's go. Let's see. So
Keep an eye on it.
this is false, so we know because of the
No!
But wait. Okay.
Do them in the right order of operation. The curls
Okay, so
have to
this
both be false.
must be false. Must be false. Therefore, this must be true. I mean, so we can transfer the D's and Z's. This is true. This is false. Oops, what am I doing? Yeah, this is true. This is true, not false. Because we know this, we have to maintain this truthfulness, so we know that this is
How about the curl first?
false, right? Is that correct? Alright, so now this is true, because we're maintaining this. So we have to, this must be true then. No, this must be false. So then we know that this is false. And this is impossible right here.
Oh, that's possible. Well, if Z is true and Y is false, then horseshoe is false.
Right, okay. So true and false makes that impossible eventually, right?
Yeah, the contradiction is actually found in that first horseshoe.
Right here, right?
No, the first horseshoe.
Oh, this one, yeah.
Yeah.
Can't happen, right? Okay, sorry. That wasn't the best thing.
That's okay.
At least
I'm not gonna look at where you put X's. Is that what you guys found for that?
yeah.
Good, let's do another one. This looks kind of familiar.
Did we do that one?
Yeah, we did, huh?
Yeah.
So sorry. Didn't do this one. manageable. I'll get you started. I know the truth values of 8 symbols. Well, so do you, right?
I don't know, I haven't looked at it.
We know the truth values. The royal we. Yep. Anybody want to come up and knock this out? I think we might have to use some slashes here. Might possibly have to try a combo or two. Maybe not. Well, then I guess I will. We know the truth values of all 6 of these horseshoes. Probably not the place to start. It's not going to be very profitable because they're all true horseshoes, and that doesn't help much. That's not a good place to start because there are 3 circumstances under which a dot is false. I think this is your beginning point right here. Do you agree? Yeah. The only time a dot is true is when both conjuncts are true. So now we can transfer some truth values to every V, there's only one of them. And every X, there's only one of those. That might be helpful, might be helpful. Now, of those 6 horseshoes, don't you think the first premise is the place to proceed because you know more information about those horseshoes? Yeah. See, I would suggest you don't put T's in for all those horseshoes all at once. This is the most profitable place because we know something about those antecedents. And if you reflect for a moment, when the antecedent of a horseshoe is true, it matters what the consequent is. So this is probably going to open up some assignments for us. Okay, again, we are trying to preserve a true dot. Both conjuncts, or in this case, the horseshoes, have to be true. Yeah, that does open up a lot for us. What can you tell me, top premise from left to right? What's the first symbol you come to whose truth value you know?
The way, I mean the kernel.
What does it have to be?
True.
Anybody not understand why?
And the Y has to be true.
The what?
Y.
Well, W has to be false.
Yeah, let's do the W first.
The W has to be and there's another W in the next line. And then the Y has to be true for the same reason that the W had, or I mean that the curl had to be true. And there's a Y in the next line.
Why don't you just come up and do it?
Okay.
Don't bring a notebook though.
We already did it, I can just copy it.
Yeah, no, but we don't want you to copy it because then we can't see the procedure.
Sorry.
What's in the little book?
Notes.
How would you know the book? Okay. So then we know that this is true. And we already know that both of these. Can I fill
Yeah.
these in as true?
Just 2 at a time.
Okay. We already know that both of these are true because of this, or whatever reason we knew.
Because they're conjuncts of a dot.
There you go. That's why. Same reason as this. And then if this is true and that's true, then this has to be true, which means this one is true.
She's even getting out of the way so you guys can see.
And if that's true and that's true, then this has to be true, which makes this false. Which means we can
Circle that T under the dot.
Which means we can move false down here. Then we come here for this to be true, same thing as before. This has to be true. This has to be true. And if that's false, this is true. And if that's true and that's true, then this has to be true. True down here. And then both of those are true. This has to be true, which makes B false.
Oh, why don't you circle that T under the dot?
And then if B is false, then you put false right here. This is true, and that's not possible, so we know that the argument is valid.
I only have one criticism.
Okay.
Too many thises and that instead of the names of the components.